When did Earth's crust form? Is it all the same, or are there differences between crust of the continents and crust of the ocean basins? We will look at those questions and more in this part of our Dynamic Planet unit. As Earth formed, heat from the impacts of countless asteroid and comet-sized bits of debris from the protoplanetary disk, along with heat from gravitational compaction and radioactive decay of heavy elements, all contributed to melting of the growing planet. Heavy material sank to the center forming our planet's core, while lighter material rose to the surface. This process eventually formed our planet's internal layers as well as the Earth's crust. Until it cooled enough to solidify, Earth's crust was a vast magma ocean. Ocean crust is made from high-density rock. These rocks are formed from mafic minerals and are dark in color. Mafic minerals are higher in iron and magnesium and lower in silica than are felsic minerals. Basalt is a rock common in the ocean crust. Continental crust is granitic, and has a lower density than the basaltic ocean crust. Granite is made of felsic minerals, which are richer in silica than are mafic minerals. Common minerals in granite are quartz, feldspar, and mica. The early basaltic crust was altered when granite intruded from below and formed cratons. Cratons are the ancient cores of today's continents. Being made of granite, they are lower in density than the ocean crust, allowing them to form continents that are above sea level. In North America, the craton is exposed at the surface in the Canadian Shield. This area was exposed by erosion from continental ice sheets, the most recent of which departed that region around 11,000 years ago. Kimberlite pipes have been found in association with cratons around the world. Kimberlite pipes contain diamonds. Diamond mines around the world are associated with these structures. Why do you think diamonds have been found in Michigan? You will either get to do a lab where you find the density of granite and basalt, or you will watch a video of the lab. Whichever you are assigned, stop the video here and do, or watch, the lab before you continue. Our planet's molten iron core has provided us with a planetary defense shield, our geomagnetic field. The Sun releases a constant stream of high-energy particles called the solar wind. Without our shield, Earth may have lost much of its atmosphere and water. This is what most likely happened to Mars, which does not have a planetary magnetic field. Our field does change. It is currently weakening and may be getting ready for a pole reversal again. Earth rotates on its geographic axis. But geographic north and magnetic north are not the same thing. In fact, our north magnetic pole is wandering, currently heading towards Siberia. This image shows map declination, or deviation from geographic north. In our part of Michigan, there is about a 4-degree difference between magnetic and geographic north. This map shows the path our north magnetic pole has taken in its wanders from 1831 to 1994. Remember, polar wander is accelerating, with the north magnetic pole rapidly moving towards Siberia. Have students do the polar wander activity.